Hello friends, welcome to this third video on central limit theorem. This video will help you to identify a problem and how to apply central limit theorem for the given problem. The problem is a random sample of size 100 is taken from a population whose mean is going to be 60 and variance is 400. With what probability can we assert that the mean of the sample will not differ from mu is equal to 60 by more than 4, and this has to be estimated using central limit theorem. So we will take the clues from the question. Before, in the question paper, we need to identify what the question is and then how to apply and go about it. So the first clue word is CLT, central limit theorem. CLT, the central limit theorem, deals with two types of problem. One is going to be the X bar problem and the other one is going to be SN problem. X bar stands for average or mean of the data and SN stands for the sum or total of the data or the random variables. Okay, so we will see what is this problem talking about. With what probability can we assert that the mean of the sample? So the keyword given here is mean. Therefore, we are going to stick on to apply the CLT for X bar. So having fixed that, we will now say what is going to be our step 1, fixing the formula for your CLT. So we need the formula for X bar. Let us now recollect the formula for X bar. The formula for X bar is X bar follows normal distribution with this is going to be my mean and the second one is going to be my standard deviation. So the formula for X bar is fixed. Second one, fix your datas. The datas are sigma, mu and n. From the problem, collect all these datas. What has been said? It has been said the size is going to be 100. So this tells me n is going to be 100. What is the second data set? We have been said mean is going to be 60. This is the mean of the population. Okay. So what does the population mean denoted by? Population mean is denoted by our mu. So we have been given mu is going to be 60. What is the third thing which has been given to us? Variance is 400. So stick on to your formula that variance is given by sigma square and not sigma. Keep in mind sigma square is 400. So what is sigma? Sigma is square root of 400 which is going to be 20. So my step 2 is also over. What is my step 3? Step 3 is fixing the data in the formula number 1. So I say X bar follows normal distribution with mu. What is my mu here? It is 60, comma. What is going to be sigma? 20 divided by what is square root of n? It is square root of 100. So this can be reduced as X bar follows normal distribution with 60, comma. This is going to be square root of 100. What is square root of 100? Square root of 100 is 10. And you have 20 by 10. What is 20 by 10? This makes it as 2. Therefore, I have X bar to follow normal distribution with mean 60 and standard deviation 2. Now, problem for point number 4 or step number 4. What is step number 4? Identifying the question from the problem. So, what is going to be the question asked? The question asks us, with what probability can we assert that the mean of the sample will not differ from mu is equal to 60 by more than 4? So this is my question. So how to reframe it? We want the probability that the mean of the sample. What is the mean of the sample given by? Mean of the sample is going to be given by my X bar. This X bar will not differ from where 60. By how much quantity? By more than 4. So it cannot move 4 units beyond either in the left or to the right. So when I move 4 units to my left, what will I arrive at? I will arrive at 64. When I move 4 units towards my left, then what will I arrive at? I will arrive at 56. Say that this X bar cannot deviate more than 4 from my 60. So this says that probability of X bar has to vary between the lower limit 56 and the upper limit called as 64. So this is my question. So what is your step 4? Fix your question from the given problem. From 60, I cannot move more than 4. So if I move to the left by 4, I get 56. And if I move right to the 4, I get 64. So my x bar can just move between 56 and 64. Now this problem is going to be in terms of x bar. I now have to convert this problem in terms of z. So when I convert it into z, what does this 56 become and what does this 64 become? So that is going to be our next process. So we have probability of 56 less than z less than 64. And what does our x bar follow? It follows normal distribution with mean. What is going to be the mean of the data? It is going to be 60 and the deviation is 2. So I take 56. You know the formula for z? X minus mu divided by sigma. Now 56 minus mu. What is mu? 60 divided by 2. Less than or equal to z. Less than or equal to, this is going to be our x bar. I'll have to convert it into z. So 64 will now become 64 minus 60 divided by 2. So this is the probability I need to estimate over here. So now simplify using your calculator. The first data will be 56 minus 60. It is minus 4 by 2. Less than z. Less than 64 minus 60. It is 4 by 2. So you have this as probability of minus 2 less than or equal to z less than or equal to 2. So this is the quantity I have to estimate. What distribution it follows? It follows normal distribution. So draw your normal distribution graph. We know that the normal distribution graph is going to be a bell-shaped graph. So in this bell-shaped graph, we have the center line to be denoted by z is equal to 0. And now this varies between minus infinity to plus infinity. The first point I want is z equal to minus 2. My z equal to minus 2 will lie in the negative region. So this is my line z is equal to minus 2. And where will be my z is equal to positive 2? It will be lying towards your positive side of your z. So this will be my line z is equal to plus 2. What is my requirement? My requirement is the region between these two portions. So this shaded portion is what is my requirement. But I know that the table or the normal distribution chart cannot give me the values for negative quantity. Therefore, I take the mirror image because this is going to be identical on both sides plus 2 minus 2. So how I can rewrite this as? I can rewrite this as 2 times probability 0 less than z less than or equal to 2. That is what I do over here is I consider this portion and then shift it to this portion so that I make it as 2 times of the portion over here. So already the green portion is there. If this is going to be flipped, this yellow portion, then it will become 2 times of the value. Now go to the table and now get the data. What you want the data is for 0 to 2. So from the center to 2, how much is your table value? So 2 can be considered as 2.00. In the table, search for your 2.0. Where is our 2.0? Here. And the second value is also 0. So 2.00. What is the table value? 0.4772. Therefore, probability of 0 less than z less than 2 has been given as 0.4772. But what is our requirement? Our requirement is 2 times of the quantity. Therefore, 2 times of the quantity will be 2 times of 0 less than z less than 2 will be now equal to 2 times of 0.4772. So multiply with your calculator, get the answer to be 0.9544. So this will complete the problem on the deviation from your 60 by not more than 4. Thank you.